Okay, for this video, we'll be discussing the molecular geometry of CF4. First off, we need to construct our Lewis structure. I have already designed it right here, and I'm going to tell you why looking at this doesn't really give us an idea of what the molecule actually looks like. But first, when we construct our Lewis structure, we first need to figure out how many valence electrons each atom will contribute to the molecule. Carbon is found in group 4A, or group 14, so it contributes 4 valence. Fluorine is a halogen found in group 7A or group 17. So put a 7 here. We're adding those. But keep in mind this 7 is going to have to be multiplied by 4 because we have 4 fluorines. So if you add all that up, it should be 32. So let's count this. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 8 times 4, 32. We're good to go. And it's a good idea to check the formal charges, but we can already tell these atoms have a 0 formal charge, so it's neutral, and the molecule is supposed to be neutral, so that checks out too. So, how many atoms is this central carbon connected to? It's connected to 1, 2, 3, 4. 4 atoms, okay? How many lone pairs does this central carbon have? 0. So, we go down here to our steric number. Our steric number was 4. We have 0 lone pairs, so it's this first example right here, tetrahedral. So let me type that out. Our molecule is tetrahedral. And what is our bond angle? Well, if we just look at our Lewis structure, it looks like it's 90 degrees. However, that's not the case at all. It's not forming a right angle. It is actually 109 degrees. Some textbooks have it as 109.5 degrees, but 109 degrees is the correct answer. The reason why it's not 90 degrees is because the valence shell electron repulsion theory, VSEPR, and these atoms like to be spread out as far as they can, so there's the least amount of repulsion. And if you look right here, you can see that this atom, let's say, let's just draw that to make it look even better. So this carbon, I'm just gonna move it, is actually like this. It has a fluorine down here with the bond attached to it, and it has another fluorine atom pushed all the way over here, and they have it drawn as a triangle. Now, what does this triangle actually mean? It simply means that this molecule, or this atom connected to this carbon, is coming out of the plane. It's three-dimensional. It's coming out of the screen. Now, this fluorine over here is situated over here, but it is going into the plane. That's what this dashed line means. It's going in to the plane. And our last fluorine is up here, and it simply just has a line, meaning it's in the plane. So solid lines means it's on the plane. This dashed line means it's going inside of the plane. Triangle coming out. So if we actually drew the angles, so right here is 109, right here is 109, right here is 109, right here is 109. So this is what your molecular geometry for CF4 is. It's tetrahedral with a bond angle of 109 degrees. And that's it for this video.